discuss about sulfur system. Before we start our today's topic, let's take quick recap to our previous lecture. We will discuss about water system. There are three phases exist. There are curves, there are areas, there are one triple point. Curve OA is called vaporization curve. Curve OB it is called sublimation curve of ice. Curve OC it is called melting point curve, or you can say fusion curve. Then after curve OB and degree of freedom for curve is 1. That means this system is univariant, and so either temperature or pressure must be fixed to define the curve. For areas, there are three areas: AOC, BOC, and AOB. And for area, degree of freedom is 2. That means this is bivariant. So therefore, both temperature and pressure must be fixed to define the system. Then triple point, where the system is equilibrium at that point, and for this degree of freedom is 0. So there are no change. That means it is a 0 and non-variant, right? So now we move our topic, that is called sulfur system. Now you all know sulfur exists in 4 phases. 2 solid polymorphic phases, that is rhombic sulfur, denoted by Sr. Melting point is 114 degree on Celsius, and another one is monoclinic sulfur, Sm. Melting point is 120 degree on Celsius. Another one is sulfur liquid and sulfur vapor. So sulfur exists in 4 phases. એટલે કે સલ્ફરમાં 4 phase જોવા મળે છે: rhombic, monoclinic, sulfur liquid અને sulfur vapor. Now component and phase rule. How many components over there, and what is the phase rule? So all the 4 phases can be represented by the only chemical individual sulfur itself. 4 ફેઝ છે બરાબર, બટ આપણે એને એક જ ફોર્મ્યુલા વડે દર્શાવી શકીએ. This is only sulfur, hence it is one component system because here one component is present. And phase rule, you all know equation F is equal to C minus P plus 2, where C is equal to component, P phase, and 2. So F is equal to 3 minus P, right? Now, so this is a diagram of sulfur system, pressure versus temperature, because this diagram is PT diagram, right? Here 4 phases available. In the left side, solid, vapor, solid monoclinic, and liquid. So this is the block diagram of sulfur system. Okay, now we discuss about curves. How many curves? So here first of all we discuss about curve AB. You can see curve AB, left side, right? So sublimation curve of rhombic sulfur. This curve represent the vapor pressure of rhombic sulfur in a different temperature, right? मतलब 2 phases rhombic sulfur and vapor sulfur are in equilibrium along with AB, and point B is a transition temperature. You can see point B transition temperature 95.6 degree Celsius, at which rhombic sulfur changes reversibly into monoclinic form, right? Then curve BC. Curve BC is sublimation curve of monoclinic sulfur. You can see in the diagram curve BC. This curve represents the vapor pressure of monoclinic form of different temperature. In 2 phases, monoclinic sulfur and vapor sulfur are in equilibrium along with the curve BC. And at point C, temperature is 120 degree. You can see the temperature of 120 degree at point C. The monoclinic structure liquefy. ત્યાંથી monoclinic liquefied માં convert થશે કયા temperature 120 degree Celsius, and this is called the sublimation curve of monoclinic sulfur, right? Moreover, curve CD you can see curve CD, right side, vapor pressure curve of liquid sulfur. It represents the vapor pressure of liquid sulfur at a different temperature. And the two phases, liquid sulfur and vapor sulfur, are equilibrium along with CD. Another one is curve CE. Curve CE is a fusion curve, or you can say melting curve of monoclinic sulfur. You can say curve CV. Now curve BE is a transition curve of solid sulfur. Curve BE. See, curve BE. Then curve EG is a fusion curve or melting curve of rhombic sulfur. Right? So this is all about curve. Now phase rule for curve. So at any curve, phase rule becomes, એટલે કે કોઈ પણ curve માટે you can see curve A, B, C, E, E, G, right? For any curve, phase rule becomes F is equal to C minus P plus 2. Now, you all know this is a one component system because this is only one formula, sulfur. So component is one. Here phase. Now phase 2. Why 2? Because there are two phases in all the curve, like curve AB. So that means here a sublimation curve of rhombic into vapor, right? So two phases present in the each curve, and plus 2, that is called 1. So degree of freedom of the system is 1. That means it is univariant. Therefore, either you can change temperature or pressure must be fixed to define the curve, or must be to fix the system, right? So this is a curve for all this is a phase rule for all curve is 1. Now triple point. You can see the triple point where I can underline the where I can put the red drop. Triple point B, C, and E. See, phase rule becomes F is equal to C minus P plus 2. So for triple point, you all know triple point phase કેટલા હોય? 3 હોય, right? So here the system is non-variant. So first we discuss about triple point. Our triple point is B, right? B. You can see B. So this curve meet where three phases rhombic, monoclinic, and vapor sulfur exist in an equilibrium. Second triple point C, where three phases can coexist in equilibrium with monoclinic sulfur, liquid sulfur, and vapor sulfur. And triple point C, at point C, three phases rhombic, monoclinic, and liquid sulfur triple point E exist in equilibrium, right? So for triple points, the system is non-variant. So degree of freedom of system is 0. That means it is non-variant. So here already this system in equilibrium condition. Now areas. So this is area A, B, E, G rhombic sulfur, B, C, E, B monoclinic sulfur, D, C, E, G sulfur liquid, A, B, C, D sulfur vapor, and for area phase rule is 2. So this is called system is bivariant. The degree of freedom of this system is 2. Therefore, both temperature and pressure must be fixed to define the system at any point in the areas. Now metastable equilibrium. There are metastable equilibrium also over there. Curve BF, curve CF. So curve BF is a sublimation curve of rhombic sulfur, and curve CF is a vapor pressure curve of supercooled liquid sulfur, and curve FE is a fusion curve of metastable SR. And here also one triple point is F. You can see in our figure, so you can understand better. Three areas, one triple point F, and three areas also available: ABFE, ABFCT, and DCEF, supercooled liquid sulfur. The transition of rhombic sulfur to monoclinic sulfur should be quite slowly, right? Should be quite slowly. So if the heating is quite rapid and the transition of point O passes without Sr getting changed to Sm, so Sr exists in a metastable equilibrium with a vapor along the dot curve. This metastable curve I can draw in a figure by dotted line. You can see there, right? And triple point, their metastable curve at point F, the known as a fourth triple point, is so coexistence of metastable phases of Sr, Sl, and Sv. That means rhombic, liquid, and vapor. The temperature F point A is a melting point is a 114 degree Celsius of metastable rhombic sulfur. So thank you guys for listening me.